Thank you for joining me in today's program. In this video, we shall treat another method in which we can use to find a binomial word expansion. So the topic for today is now binomial series using combinatorics. Okay. In our last video or former videos, we have treated how we can use Pascal's or Blaise Pascal's triangle to find the binomial coefficients, okay, of a given binomial expression. We have treated how we can actually use the binomial formula, or how we can actually multiply out, okay. So in today's program, the main aim is for us to see how we can use word combination, okay, to find the binomial word expansion. To find the binomial coefficient in which in standard form, okay, we find the binomial expansion. Now, let's start. First of all, we have to know about or have some knowledge about what combination, okay, though we have not gotten to combination, but that's our next topic, okay, after today's video. But now, there are many ways to represent combination. We can have n combination R, okay, which is equals to n combination R, which is equals to n choose R. Okay, the C actually means choose, okay, or you call it what combination, right? Okay, at this juncture, n actually the n decreases, okay, n of n minus 1, okay, then of n minus 2. That is the power of this n, or n means the number, all right, okay, of the observation. It must be decreasing, okay, whereas R, okay, will be increasing, all right. R will be increasing, okay, from 0 to 1, from 1 to 2, 2 to 3, 3 to 4, whereas n will be decreasing from n to n minus 1 to n minus 2 to n minus 3 in that case, okay. So let's clean this, okay. So we have seen how we can actually represent a combination n combination R, the first one, or n combination R or n combination R, okay. So each of these symbol you can use. Suppose we have a binomial of the form a plus b raised to the power n, okay, and n is a positive integer, okay. All right, now using combination, we can have n combination R to multiply, taking the first term of the binomial, which is a. That a we shall have the power of the main or original binomial, which is n, multiplied by taking the second term of the binomial, which is b. Then b will be raised to R. So it means that whatever R is, that is what b will be. Then plus another n combination R plus 1. Okay, because we said that R, the power of R will be or the R will be increasing, okay, in numbers, okay, times a raised to the power n minus 1, okay, n minus 1, then times b raised to the power R plus 1, all right. Again, we have n combination R plus 2 multiplied by a raised to the power n minus 1 minus 1 is n minus 2. All right, then b times b raised to the power R plus 2, okay, and in that order till infinity, because the number of or the value of n is not known. So this is actually how we can represent this, okay, binomial expansion using combination. So it means that n combination R here shows the binomial coefficient, okay, of the first term. N combination R plus 1 here shows the second binomial coefficient, okay, of the second term. Here n combination R plus 2 shows the binomial coefficient of this third term, okay, and in that order. Now let us clean, okay, to use some numeric examples. Please pay attention, as this example is quite a little bit confusing, okay. So now suppose we have this binomial of the form 2 square root of x minus 3 all raised to the power 4. So we have seen that our n is now known to be 4, okay. So now how do we find the binomial coefficients, okay, of these, okay, using combinatorics? Now we shall have The first coefficient of the binomial will be 4 combination 0 at this point r is 0, okay? Multiplied by what? 2 square root of what? X raised to the power what? The power of the original word binomial, which is 4. Again, multiplied by what? Multiplied by what? Minus 3 raised to the power what? Minus 3, we take the power of what? R, which is what? 0. Okay, the number R, which is what? 0, okay? Then we are done with the first term. Plus, again, 4 combination 1. Have you seen that the number R has increased to 1, okay? Multiplied by, multiplied by 2 square root of what? X raised to the power what? When you subtract 1 from 4, you shall have what? 3. Multiplied by what? Minus 3 raised to the power what? When you add 1, okay, which is 1, all right, because that is the number R is having, okay. Then plus, again, the third term will be 4 combination 2, then multiplied by 2 root X raised to the power. When you subtract 1 from 3, you shall have 2. Then multiplied by what? Minus 3 raised to the power what? 2. Okay, whatever number R takes is what the power of what? The second term of the polynomial will take, okay? Then plus, what's the third one? We now have 4 combination 3. That will form the fourth coefficient, okay, of the binomial. Multiplied by 2 root X, all raised to the power what? When you subtract 1 from 2, you shall have what? 1. Okay? Then multiplied by minus 3 raised to the power what? 3. Plus, the last term will be 4 combination 4. Okay? Multiplied by 2 root X raised to the power 0. That when you subtract 1 from 0, from 1 you have 0. Multiplied by 3 raised to the power what? 4. Okay? So at this point we stop. Alright? So please make sure you copy this out for us to work out, okay? 4 combination 0 to 1 to 2 to 3 and to what? 4. Okay, so we shall work them out to have the values, okay? That's for instance now what I mean is that the first coefficient 4 combination 0, okay, is equals to 1. The second coefficient 4 combination 1 is equals to 4. The third coefficient is 4 combination 2 is equals to 6. Okay. The other one is 4 combination 3 equals to 4. The last one is 4 combination 4 equals to what? 1. So let us actually work this manual, right? To see how we got this, okay, without using word calculator, okay. Combination is a very fast algorithm for this, okay, but that is with the use of what? Calculator, okay, but let us do it manually. Please make sure you copy out this, okay, because after, when I find all these coefficients here, okay, I will now apply straight, okay. So make sure you copy out these, okay, as they are arranged here, all right? So I shall now replace everything, okay. Whatever I have here, I shall replace that with this, okay, with this, and in that way, okay. So please copy them out right now. All right, I guess you have what? Copied them out, okay. So now let us clean. So now we have cleaned. Now for the first one, 4 combination 0 is equal to 4 combination 0 is equals to, the formula here is well, make it like this, okay. N combination R equals to n factorial over what? N minus R factorial R factorial. Okay, this is the formula for what? Combination, okay. Just like how do we get to? Anyway, it has a proof, okay. For instance, for permutation, N permutation R equals to N factorial over N minus R factorial. Alright? So it means that when we divide N permutation R by R factorial, okay, we shall have our what? Combination, okay. Actually, at this point, N permutation R over R factorial is equals to N combination what? R, which is equals to, when we take the reciprocal of this divisor here, okay, mind it is R factorial over 1, okay. The reciprocal of it will give me n factorial over n minus r factorial times 1 over what? R factorial. Okay, so when you multiply the two, okay, you have what is given here. So that's the formula. So now let's clean, okay, to do the real thing. Alright, so now for the first one we have 4 combination 0 is equals to 4 factorial all over 4 minus 0 factorial 0 factorial. Okay, we know that 4 factorial is 1. Okay, now we shall say that, okay, you know that 4 minus 0 is 4, right? So 4 times 4 times factorial is 4 factorial, then 0 factorial. The law of what factorial is that 0 factorial is what? Unity, okay? So in that 0 factorial we shall have 1 there, okay? Do you see, since we have 1 now, therefore we have 4 factorial all over 4 factorial times 1. 1 changes nothing, Abi. Now, okay, we can now cancel out for us to have 1. So do you see how 4 combination 0 can give us what? 1, okay? Please, the slangs I use are B of a thing, okay? It's a Nigerian thing, so please just ignore it, alright? The main thing is that you're getting what we are doing here. So for 4 combination 1, which is 4, I have 4 factorial over 4 minus 1 factorial 1 factorial equals to 4 factorial over 4 minus 1 is 3. 3 times factorial is what? 3 factorial, then 1 factorial, okay? We know that, also we know that 1 factorial is also what? 1, okay? So 1 times 3 factorial is also 3 factorial. Now we have, therefore we have 4 factorial is 4 times 3 factorial over 3 factorial, okay? At this juncture, we can cancel out 3 factorials, okay, for us to have 4. Okay, so we see that 4 combination 1 is now 4. All right, let us clean it up for us to do the other ones. Now we go to 4 combination 2, right? Okay, equals to 4 factorial all over 4 minus 2 factorial 2 factorial. All right, 4 factorial is 4 times 3 times 2 factorial all over 4 minus 2 is 2 times factorial is 2 factorial, then 2 factorial. All right, so we can actually divide these 2 factorial and this 2 factorial. We are left with 1 2 factorial here, and 2 factorial is also 2. That is 2 times 1 is 2. Then 4 times 3 is 12, right? So 4 times 3 is 12 all over 2 factorial is what? 2 divided, you have what? 6. Okay, so 4 combination 2 gives us what? 6, right? So we have that. We clean for us to have 4 combination 3, which is 4. Let's see how. We have 4 factorial all over 4 minus 3 factorial 3 factorial. Now 4 factorial is 4 times 3 times 2, right? Times 1 factorial all over 4 minus 3 is 1. Okay, 1 times factorial is 1 factorial also, times 3 factorial, okay? So now we can strike out this, so though it changes nothing. After all, 1 factorial is 1. When 1 multiply all these things, nothing changes, okay? So now 3 factorial is 3 times 2 times 1, which is 6, okay? So we have, in our divisor, we have 6, okay? 4 times 2, 4 times 3 is 12. 12 times 2 is 24, okay? So the 24 divided by 6, okay, gives us what? 4, right? Okay, so we have what? 4. This by itself 1, this by this is 4, okay? So 4 combination 3 is 4, all right? So we go to the last one. That was clean. Do you see how interesting this thing is? Okay, we have 4 combination 4. Okay, it doesn't matter. It could be 4 combination 4 equals to 4 combination 4 like we did before. Okay, or equals to 4 combination 4. All right, so nothing happens. Okay, so we have 4 factorial all over 4 minus 4 bracket factorial 4 factorial, right? Already 4 minus 4 is 0 times factorial is 0 factorial, right? And 0 factorial is 1. So now we have 4 factorial all over 4 factorial. Cancel out, we have 1. So 4 combination 4 is also what? 1. Now we have our thing to be, since we have gotten all these, okay, let us clean and replace those combinations, okay, with normal numbers, okay. For 4 combination 0, we shall have 1. So in our this thing, it should be 1 multiplied by. Now have 1 multiplied by that is from the first term, okay, 2 raised to the power 4, okay, root, or simply since we have root s, okay, so we should be root raised to the power 1 over 2 raised to the power was 4, okay. Then multiplied by minus 3 raised to the power 0, but we know that minus 3, anyway, let me put it, okay, minus 3 raised to the power 0, okay, then plus, then 4 multiplied by 2 raised to the power 3, x raised to the power 1 over 2 raised to the power 3, multiplied by minus 3 raised to the power 1, okay, plus 6 multiplied by 2 raised to the power 2, x raised to the power 1 over 2 raised to the power what? 2, multiplied by minus 3 raised to the power 2, plus we have the third one to be, the fourth one to be 4 multiplied by 2 raised to the power 1 root x, that is x raised to the power 1 over 2 all raised to the power 1, okay, then multiplied by minus 3 raised to the power what? 3, plus the final term 1 multiplied by 2 root x all raised to the power 0 minus 3 raised to the power what? 4. Okay, so now we know that by indices, okay, the zeroth law of indices is that says that minus 3 or raised to the power 0 is 1, okay, that is minus 3 raised to the power 0 is equal to 1. Again, minus 2 root x raised to the power 0 is also 1, okay, so we substitute, all right, from the first term, 1 times this, everything here, it remains 1, okay, so we now have raising 2 to 4, okay, we shall have 16, okay, x. Now here, 1 over 2, okay, multiplied by 4 from that power, okay, will give me 2, right? So it means that 2 cancel this 4 here for me to have 2, right? So here from the second term, I have minus 3 to the power 1, right? Minus plus is what? Minus, okay? So 3 times 4 is 12, okay? 12 times 2 raised to the power 3 is 8, okay? So 12 times 8, all right, will give me 96, okay? I have 96, again, what power? 3 times 1 over 2 will give me 96, square root of what? X raised to the power what? 3, okay? Or simply minus 96, x raised to the power what? 3 over 2, okay? Then, again, from this term here, minus 3, because the power here is an even number, so minus 3 raised to the power 2 is what? Plus, okay? So plus 9, I'm sorry, yes, okay, plus 9, right? Then 9 times 6 gives me a number 54. 54 times 4 gives me 216 also, okay? So I have 216, then using these 2 and these 2 to cancel out, I have what? X alone, all right? 216x, okay? Again, from the fourth term, I have minus 3 raised to the power 3 will give me a negative of a particular number, okay? Minus 3 raised to the power 3 is minus 27, okay? Then minus 27 times 4 gives me minus 108, okay? times 2 gives me minus 216. All right, so I shall have minus what? 216. Then for the x, okay, I have just simply root x. All right, then for the last one, which is this one, okay, minus 3 raised to the power 4, or minus 3 raised to the power 4 gives me 81. We note that 2 root x all raised to the power 0 is 1. So 1 multiply everything here, nothing changes, so I shall have what? Plus 81. So do you see actually how we can use combination, okay, to look for the binomial coefficients of a particular binomial expansion? Please try to memorize this very well, okay? At least you've understood how you can actually use 3 different ways, okay, to approach a binomial problem. All right, trying to find the coefficients of the particular binomial. Please, I'm responsible for any written error or mistake here. Thank you for watching. Hope you found this helpful. Please do subscribe to my channel.